For most of history, we thought we were the center of everything. But science has shown us, step by step, that we're actually on a tiny planet in a pretty unremarkable corner of the cosmos. And that realization has led to one of the biggest, most mind-bending questions we've ever had to ask. In a universe this huge, why does it seem so empty? This is the Fermi Paradox, a mystery that takes us to some really fascinating and honestly kind of terrifying places. So, let's dive in. Okay, to really get a handle on the scale we're dealing with, just look at this number. For every single grain of sand on every beach and desert here on Earth, there are estimated 10,000 stars out there in the universe. I mean, the number of potential planets, potential chances for life, is just so big it's hard to even wrap your head around. But with all those chances, all those worlds, what have we found? Absolutely nothing. All of our telescopes, all of our efforts listening to the skies have been met with total, complete silence. No signals, no spaceships, no signs of anyone else. And that contradiction right there is the heart of the whole mystery. So yeah, why is it so quiet out there? This is the question that keeps astronomers and philosophers up at night. It's called the Fermi Paradox, and trying to solve it is like being a detective at a cosmic crime scene, where the mystery isn't what happened, but why it seems like absolutely nothing is happening, anywhere. The whole thing gets its name from the brilliant physicist Enrico Fermi. The story goes that back in 1950, he was having lunch with some colleagues, talking about UFOs and aliens, when he just suddenly blurted out this really simple question that changed everything. Where is everybody? And this is super important to understand. Fermi wasn't just asking, do aliens exist? He was asking something much deeper. Why aren't they here? I mean, think about it. His basic math showed that even a civilization with tech that's not much better than ours could colonize the entire galaxy, and it wouldn't take billions of years, just maybe tens of millions, which is basically a weekend in cosmic time. The fact that Earth is just sitting here unvisited is the real puzzle.
So let's start looking at some possible answers. The first category of solutions is maybe the simplest, and also maybe the loneliest. It says the silence is exactly what it sounds like. We don't see anyone because there's no one else there.
This brings us to the rare Earth hypothesis. The idea here isn't that life itself is rare. Simple little microbes could be all over the place. The argument is that the long, crazy, improbable series of events needed for complex, tool-using, intelligent life like us, well, that chain of events is so unlikely it might have only happened once, right here.
And what's so powerful about this idea is how the odds just keep stacking against you. It's not one single thing. First, you need to be in the perfect neighborhood in the galaxy to avoid getting fried by radiation. Then, you need a huge planet like Jupiter to act as a cosmic bodyguard, taking hits from asteroids. You even need a giant moon, probably formed from a super rare planet-sized collision, just to keep our climate from going haywire. It's like you have to win the lottery over and over and over again. Miss just one of those steps, and you don't get a complex civilization.
A similar idea, but with a twist, is called the Great Filter. This theory suggests there's some step along the way from primordial ooze to a star-faring civilization that is just almost impossible to get past. It's like a giant wall or a final boss in a video game that almost nobody can beat. The silence we hear is just the sound of every other species failing to clear that hurdle. Now, there's a good news version of this. It's the idea that the Great Filter is already behind us. Maybe the hardest part was just life getting started in the first place. Or maybe it was the jump to complex cells that took like 3 billion years on Earth. If we've already passed the hardest test, then maybe our future is wide open. We're the ones who made it.
But, and this is a big but, that has a really dark flip side, and it leads to this chilling quote from the philosopher Nick Bostrom. Think about it. If we go to Mars and find simple fossils, it means that life starts easily. It's common. That would mean the first step isn't the Great Filter. And that would be terrifying news, because it would strongly suggest the filter, the thing that stops civilizations, is still somewhere in our future. An empty universe, in this view, is actually the best thing we could possibly hope for.
Okay, but what if we're not alone? What if the aliens are out there, but they're just hiding, or we can't see them for some reason? That brings us to our second big category of answers. So here's a popular one, the zoo hypothesis. The idea is that we're basically in a cosmic nature preserve. Super advanced aliens are watching us, maybe studying us, but they have a strict look, don't touch policy. They're just waiting for us to grow up. The problem with this, though, it would require every single civilization forever to agree to the exact same plan. It only takes one curious species or one expansionist empire to break the silence and ruin the experiment for everyone else.
That's a tough consensus to maintain for billions of years.
Now here's a much more interesting kind of nerdy idea. It's called the estivation hypothesis. And estivation is basically hibernating to escape the heat. So the theory is that advanced civilizations aren't dead. They're just sleeping, waiting.
And the logic here is actually pretty solid. It all comes down to thermodynamics. The ultimate goal for a supermature civilization might not be building giant structures, but pure computation, running massive simulations or preserving consciousness. Well, physics tells us that computation is way, way more efficient when it's cold. By waiting for the universe to cool down over eons, a civilization could get something like 10 to the power of 30 times more processing done. So why waste energy now in this hot, youthful universe? The smart move is to go dormant, wait for the perfect conditions, and then wake up. They're not loud, they're efficient.
And that brings us to our final, and, let's be honest, our most disturbing set of answers. This group of theories suggests that the silence we're hearing isn't the sound of an empty room. It's the sound of everyone in the room holding their breath, terrified of making a sound.
This is the dark forest hypothesis. Picture the universe as a pitch-black forest at night. It's full of silent, armed hunters. And every hunter, every civilization, knows two things for sure. One, you have to survive at all costs. And two, you can't be sure of anyone else's intentions. With the vast distances and the speed of light delay, true communication is impossible. So you can't ever risk trusting a stranger.
So what's the logical conclusion? Every other civilization you might encounter is a potential threat to your very existence. So the only winning strategy has two parts. First, you stay absolutely silent. You never reveal your position. And second, if you're unlucky enough to spot someone else, you eliminate them immediately before they have a chance to eliminate you. Suddenly broadcasting hello into space with our radio telescopes doesn't seem so clever. It seems incredibly naive.
And this idea connects right back to the darkest version of the Great Filter. The possibility that the filter isn't in our deep past, it's in our immediate future. It suggests that life gets to where we are, a technological species, all the time, but something always stops it from getting any further.
And this table really brings it home. What could that filter be? Well, it might just be us. The very technologies that give a species the power to reach for the stars, nuclear energy, artificial intelligence, genetic engineering, also give it the power to destroy itself with terrifying efficiency. Maybe our current global challenges aren't unique. Maybe they're the final exam for every intelligent species, and so far, nobody has passed. The cosmic silence is the sound of a graveyard of failed tests.
So, when you get right down to it, the Fermi Paradox is more than just a science puzzle. It's like a cosmic Rorschach test. The answer you lean towards, the one that feels most plausible to you, it probably says more about your own hopes and fears for humanity's future than anything else.
So who are we in this story? Are we the miracle, the first and only flicker of consciousness in a vast, dark galaxy, with the responsibility of carrying that flame forward? Are we the child, just the loud, naive species in a universe of wise, silent elders who are either watching us or sleeping? Or are we the endangered, just the latest in a long, tragic line of species to reach this point, right before hitting the wall that has silenced everyone else?
And that forces us to flip the whole question around. The real question isn't just, where is everybody else? It's about us. Millions of years from now, if some other species on some other world evolves intelligence and looks up at the sky, will they be met with the same profound, unbroken silence? Or will we have finally become the answer to their question?